Okay, good afternoon, everyone. Some students are still want to join. So again, 1 or 2 minutes, I will wait for them because only 78 students are present. So it means only 50%. So 1 or 2 minutes, we will wait for to joining all students. Okay. Good afternoon, one and all. So, dear all students, my am I audible? And my screen is visible to everyone, please.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
thank you. So, okay, once again, I will good afternoon to everyone and welcome to my today's lecture. So, yesterday means yesterday one student asking the question in your friend. So, please explain odd and even address in a short. So in that internal operations, we studied odd and even addresses. That is three instruction, first instruction, second instruction, and third instruction. So just I will open that. So this is the from yesterday's topic. Oh, where is that? These are comes right. So internal operations we taught. Yes, after this internal operations, in the internal operations we taught that is an even address and that is an odd address. Okay, so here instruction has an odd address, instruction has an even address. So as we know, what is odd? Odd in the sense all are 1, 3, 5, 7, 11, 10, like that, odd numbers. And even in the sense what? All are equal numbers means 2, 4, 0, 2, 4, 6, 8, 10, like that. Okay, so this one we say it is odd and even. So in that odd and even, I clearly mentioned here, in the memory, whatever the memory is allocated for a particular instruction in 8086 microprocessor, that memory always starts with 000. So entire, because of 8086 is a 16-bit address lines. 16-bit address lines in the sense what? These are the 0 to 15 means 1 to 16. 1 to 16 are, you say, 0 to 15th index. So that is 000 to last number FFFF. These many bits are available in the memory. So at beginning point is 00 started and ending point is FFF. This is a even number and this is also a even number. So generally we have to use it, we have to started a memory location from a even number. Sometimes, as per our requirement also, we have to start our memory at the beginning or memory from odd numbers bit also. So here I have to clearly mention in these notes, logically memory is implemented as a single one memory, means one memory into 8 memory chunks. Into 8 memory chunks means what? Parts. So the byte-wide storage locations are assigned consecutive in the address over the range of 00 through FFF. This is the entire. So it is started with 00. This memory is started with 00 and that is ends with FFF. You observe this one. Okay, that's the first point. And in the physical memory is implemented the two independent 512 kilobytes bank. In the 512 kilobytes, assume that if it is a 512 KB memory, in that we have to say even, sometimes that even numbers bank also we call it as low bank, and that odd numbers also we call it as high bank. It is our convenient, okay, as the inventor convenient. And the data bytes associated with an even address in the sense what? All are even numbers, 0000, 02, like that, up to etc, up to FFFF. So that is even numbers and reside in the low bank, with the low bank, and those odd addresses that is started with 001, 03, 05, 06, up to -1 FFFF, FFFF -1 address lines. So these are the odd and these are the even. Odd we say it is a low, even we say it is a low, and odd we say it is a high. So here we have to clearly mention this is the odd bank. Odd bank in the sense what? It is started with 00001. So even in the sense it is started with 00 and it is ends with FFFFE, and this is ends with FFFFF. Okay, so the last bit is RRF. So it is yeah, RRF -1 in the sense what? FFFF, last digit is E. So in this way we have to categorize odd and even addresses. Okay, so I think I cleared you. And also some of the theory parts I have to edit same explanations in this text. Please all of you go through it, whatever I explained now. So and again he is asking one more question. He is asking one more question, same student.
Some students are in waiting room.
Okay, sorry. Yeah, I will allow them. I will allow them. Yes, fine, fine. Okay. Whenever I started to explanation, sometimes I may forget to admit. Okay, fine. Now I give an admission to everyone. Fine. Yes. So same student. One more question he is asking. So microprocessor can be understand binary language as in the form of 0 and 1. So I think what is his question? His question is, so microprocessor is understanding only 0 and 1. only 0 and 1, but how it is understands all 16 bits of 00012 to FFF. It means that binary, octal, decimal, and hexadecimal. Is it your question, right? Who are asking this question, please? So
Yes, sir.
in this category, what we will do, we have to use the instructions. So in the addressing mode instructions, you may saw that that is a move al, that is bx comma some dl, like that. Okay, one register to another register, you have to transfer the data, because all we are human being, we have to understand easily binary, decimal, hexadecimal, octal numbers. But our microprocessor will not understand. That's what we have to use the ASCII code, as well as we have to use the instructions. We have to use the instructions. Based on instructions, we have to understand, and we have to made understand to the machines by using it into compiler. Whatever the compiler is there, that compiler is for that only. Human being understandable language is going to convert it into machine understandable language. Whatever that conversion is happened, that time all are in terms of 0 and 1 converted into in terms of 0 and 1. That's what we have to use compiler and instructions. So end of the stage, our microprocessor understands only 0 and 1, no doubt. But it is there is some conversation agents are there. What are those agents? Those agents are nothing but our instructions as well as compiler. Okay, so my answer is for that. Yes, it is right. So that's what we have to use instructions and compiler for that. Okay, so I think I cleared you all these two questions. Only these two questions I got from one student today morning and yesterday evening. So apart from this, I think no way questions. Okay, fine. So this much, I think I think you understood. Fine. So apart from this also, please any question? Still we have to discuss or still more 5 minutes if you have any questions so about yesterday's topic. If you are silent, then I understand that everything is got understand very well. So and I will move to next topic. So and one more thing I will clarify to you. So almost कभी कभी टाइम मैं अभी तो हिंदी यूज कर रहा है बिकॉज ऑफ अभी थोड़ा बच्चों ने रूरल बैकग्राउंड की है. सो उसको मे बी थोड़ा इंग्लिश टफ हो रहा है. वट एवर आई हैव टू यूज द लैंग्वेज. So now onwards I have to use Hindi. And one more thing, as our some student conveying the message, uh, I am go slow now onwards. Now onwards I will go slow. Anyhow, we have to complete the syllabus within the stipulated time. So उसके लिए हम slowly थोड़ा थोड़ा cover करते जाएंगे. So yes, because कल मैं बहुत थोड़ा topic ही cover किया था. Because actually as per time I have to complete all the addressing modes, but only I have to cover data related addressing modes. Okay, today हम ये branch related addressing modes also we have to study today. So थोड़ा थोड़ा हम पढ़ाई करेंगे, perfectly पढ़ाई करेंगे, and whatever discussion, whatever difficulties we have to base to base discuss करेंगे, call करेंगे, message करेंगे. ऐसा हम each and every corner point of the subject we have to understand. Actually that is our main मकसद है. हमारा मकसद क्या है? We have to understand each whatever the corner points. So each and every corner points we have to understand the concept of microprocessor. Okay, so fine. I think no more questions. So I will start with next portion of unit number 2. Okay, fine. So yeah, is there any questions, please? Okay. So yeah, please, I'm not able to hear your voice.
Hello, sir.
Yeah, please. Yeah. बताइए, बोलिए, बोलिए.
सर कल से मोड्स रिपीट कर.
Addressing mode, so you want to repeat? Please, I think your
हाँ,
side.
yes, sir.
Okay, fine. Yes, I will repeat it. No problem. So Okay. So again, as request from one of the students, again we have to just refresh about the addressing modes. So in the second units, we have to study architecture of 8086 and internal operations. In the internal operations, there is very small topic that is just odd and even addressing modes manipulation is there. So in this, now we have to go for a machine language instructions. Actually all the addressing, so whatever this machine language instructions is there, no, these are the helps to convert it into 0 and 1 in the form of binary. अगर हम मशीन लैंग्वेज इंस्ट्रक्शंस हम पढ़ाई करते हैं ना, वो सारा मशीन इंस्ट्रक्शन लैंग्वेजेस, सारा मशीन इंस्ट्रक्शंस, ये these are converted it into 0 and 1 for the understanding of microprocessor. So in this they have to categorize it as two parts. One is addressing modes. There are two types of addressing modes: data related addressing modes and branch related addressing modes. So for this data related addressing modes and branch related addressing modes, we have to use this general form. That one we called it as general instruction format for addressing modes. That is, at the beginning we have to use upcode. Upcode means what? It is the operational code. We call it as operational code. Operational code in the sense what? For example, in one of the example we are using move cl comma 12h. So in this we call this one as operational code. Move, whatever move is there, we call it as opcode, operational code. And these two cl and 12h, these two are operands. So here in my example move cl comma 12h, there are two operands are there. One is cl and one is 12h. So like that you compare with this one. This is the opcode is nothing but move, and operand one is nothing but cl, and operand n number of operands we have to use more than one or two. Also we have to use, but many cases we have to use two or maximum three up to your level. So here operand one is nothing but cl and operand two is nothing but 12h. 12h. So in this way we have to form the one of the general instruction format. What is that general instruction format? That is opcode and operands. That operand is top operands. It may be a one operand, two operand, three operand, up to the n operands. Okay. So now onwards, we will start with the addressing modes. In the addressing modes, as I said, two main categories. Two main categories. One category is with the data related. One category is with the data related, and one more category is with the branch related. Data related and branch related. So now we will go for first one, data related addressing modes. In that data relating address modes, there are mainly 5 main addressing modes are there. Totally 5 main addressing modes are there. Those are nothing but immediate addressing mode and register addressing mode, second one, and third one direct addressing mode, fourth one indirect addressing modes. Again in the fourth one subcategories are there. In the fourth one subcategories are there. Those are nothing but register indirect addressing mode and register relative addressing mode and based index addressing mode and based index relative addressing mode. So again in indirect addressing mode there are four types. There are four types in the fourth one: register indirect, register relative address, based index address, and based index relative address. And at the last, implied. Fifth one is main part of fifth one is implied addressing modes. So these 5 are data related addressing modes because we are going to be do the manipulation of data. Okay. So totally वो सारा इसमें 5 ग्रुप्स का कैटेगरी का है. What are the 5 groups? That is register addressing mode, direct register addressing mode, indirect register addressing mode, relative addressing mode, and implicit implied addressing modes. So now one by one we will move to that. Clearly notes I will made ready for this one for your easiness point view. So in the addressing modes, that is data related first one. So in that we will take immediate addressing modes. So immediate addressing modes means what? Suddenly, whatever we have to use the instruction, that instruction is directly go add with the address, go add with the address, that is we call it as immediate addressing modes. So in this operand, data is specified in the instruction itself. Whatever data is there, that is along with the instructions only we have to specify in this. For example, so 12h, 12h is there, it is a data in the sense what, that is the information, everyone you should agree. So this data is along with the instruction only. What is instruction here? Move is the instruction. Move is the instruction. C is what? C is a register. A, B, C, D, you studied. C is a register. What is a 12? 12 is the thing, but it is a value. Value in the sense what we say, it is a data. So this value, so in C programming also sometimes we have to use int A, B, right? A comma B. A is the one variable, B is the one variable. So you have to use int A and B, and somewhere in the program you have to assign the value A equal to 10, B equal to 20. It may be possible, or int A equal to 10 comma B equal to 20. That is also possible. So directly how to assigning the values, immediately how to assigning the values, like in the C programming. But here in the microprocessor, immediately you have to add a value to the register by using the instruction. That one we say immediate addressing mode. That is of the type of, it may be a 8-bit or it may be a 16-bit. For the 8086 it is 16-bit, for 8085 it is a 8-bit. Okay, so this is all about immediate addressing modes. So in this immediate addressing modes, I have to take this one example. Here example also I will explain you now itself. So for that, uh, okay, just a second. So first we will go through it. So it is the immediate addressing mode. So next one, I will go to, so if for example, what is instruction with the data? Data is you have to use it along with instruction only. So what is data? Data is nothing but a 12h. Okay, so that's one we have to say immediate. So next one, register addressing modes. So instead of using this 12h data, we have to use some other register. We have to use some other register along with CL. So how it is possible? So like this, move CL comma DL. C is the one register, D is the one register. What I have to made here, immediately taking value instead of immediately taking value. Okay, is there anyone is waiting? Just I'll check 1 second. Yes. Yes, sir. Okay, I given admitted. Yes, fine. So in this, immediately you have to transfer the value, you have to transfer the value through the registers. So move CL comma DL. It is a, it is, we say it is a register addressing modes, because we are using a register. Because instead of immediately taking direct value, we have to taking address. That's what CL comma DL or CX comma sorry, AX comma BX. So you note down this one is a AX, not only AX, it is a AX. So you have to use. So what is that meaning? Whatever the DL is containing, that is moves to CL, moves data from DL to CL. So in the next instruction, same here, whatever BX is containing, that is transferred into the AX register. So entire we are going to be use registers. That's what we say it is a register addressing modes. So in that we have to use again operand data. So in this operand is specified using the register. Okay, operand is specified using the register, and the data may be of 8-bit or 16-bit provided by a any kind of register, AH, AL, BH, BL, CH, whatever register you have to take. But in my case, I have to take CL and DL. Okay, this CL I have to select it, and DL I have to select it. Generally, they have selected CL and DL. Okay, so this is the instruction with the register. In the immediate, it is with the data, and that register is going to be manipulated with the data. Okay, this is the register addressing mode. Register addressing mode. So next I will move upon third one, that is direct register addressing mode. Direct. So again in the register addressing modes, two types: direct addressing modes and indirect addressing modes. So in the direct addressing modes, we have to use effective address. So these effective address is most helpful. Some calculations also I will give you. अभी थोड़ा effective address में बहुत helpful होता है वो direct addressing modes करने के लिए. So in the direct addressing modes, we have to use 16-bit effective addressing modes with the 4 offset value. Totally, the data address bus is 20 bits, right? So for that, specified in the instruction, that is effective addressing modes to data. So direct addressing modes में हम क्या करेंगे? One of the effective addressing modes we have to select. Instead of taking only the register, one of the effective address we have to take. How? For example, see here. This is the effective address. Whatever we have to specify within the square bracket, that one we call it as effective address. So move CL. So move means what? It is the instruction. CL means it's the register. This value, that is effective address value, transferred it into CL. So in the immediate, directly I have to take 12H instead of square bracket. Please remember, instead of square bracket, I have to take just 12H in immediate, but in effective addressing, we have to use square bracket. It means that this is the effective address. So this effective address is nothing but where it is located. It is located in main memory. So that main memory we call it as DS. DL is different. Don't compare with DL. DS in the sense what? It is a computer memory. So that computer memory, wherever it is containing this much value, 4321 hexadecimal value, that one is going to be transferred it into CL register. Okay, that square bracket is comes whenever that effective register is there. Please remember. Same way, 5678 also you have transferred it into CX register. X in the sense what? Generally we have to mention either it may be a low or high, even or odd. That's what we have to generally specified as X. Okay, so DS with CL or DS with H. DI is different, DS is different. DS in the sense what? It's a data segment. That data segment values. Okay, always we have to use square bracket. DI in the sense that destination index. Destination index is totally different with DS. Okay, don't confuse it. So this is about your direct addressing mode. Directly you have to fetch the values from the main memory to the CL register. That's what we have to say, direct addressing modes. So next one, indirectly we have to fetch the values from the main memory. That one is next. It is an indirect addressing mode, fourth one. In that indirect addressing modes, again four
Hello, sir.
subcategories are there. Please,
Some
any
more in waiting room.
yeah.
Waiting room.
Waiting room, okay. Aishwarya Rohite is there. I admit it. Yes. So please, all of you join in time, no? It troubles to you and me also. Whole class it gets trouble. So almost all of you try to join within the time. Okay. I know again one more time. One more friends. Shahali Linge. Okay, I admitted. See yes. Okay. Uh, so next fourth one I will move to indirect addressing mode. So direct addressing mode, directly memory you have to access with the registers. So indirect addressing mode, indirectly you have to access that. Indirectly you have to access. So in that again four categories: register indirect addressing mode, register relative addressing mode, and based index addressing mode, and base index relative addressing modes. So four categories are there. One by one, we will see in the fourth category of indirect addressing modes. So in that, the register indirect addressing modes, what we will do? Here, some of the indexed registers we have to use. That is BX in the sense base pointer. Actually, it is BP. Either it may be a low or high. We have to use X generally. So base pointer and source index. SI is nothing but source index, and DI is nothing but destination index. Along with that, we have to use effective address. So here, in this mode, the microprocessor gives two base registers, BP and BX, two base register. Either you go for BP base pointer or generally base register, as well as two index registers, DSI and DI. Two index register, source index and destination index. Either that value is from the at the source side or at the destination side. You have to use SI and DI. And also to provide offset addresses along with 16-bit, you have to use 4-bit offset addresses as we explained earlier. So again, some students are adding. Fine, no problem. Yeah. So the effective address of data is in the base register BX or in the index register that is specified by an instruction. So and one more, that is segment indicated. Segment means what? It is a parts of memory, sub parts of memory that is indicated by a two base registers. Either it may be a BX data segments and BP stack segments. So data segment and stack segment, we call it as base pointer and base register we are using. And one more, that is effective address register BX means base data segments and all stack segments and source index data destination index we have to use it. So entire this how it becomes instruction with the register because it is a base register, and also with that register is going to be with effective address. That effective address is nothing but source index and destination index, and also that data memory. Finally, we have to use the data memory manipulation. So this is about your first subpart of indirect addressing modes, that is register indirect addressing modes. So next one example for that. See, previously we have to use it under the square bracket with the value in the direct addressing mode. Direct addressing mode, under the square bracket we have to use values, but in indirect addressing modes you have to use again register. You have to use again register. That base register, it will be containing the value of DS. What is DS? It is a data segment. BX is nothing but it is a data segment. That values whatever containing the BX, that is transferred it into CL register. That is the meaning. Okay. So just you have to observe this position. Previous in direct addressing modes you have to use the direct values, but here you have to use registers in the indirect addressing modes. So next up part, that is the register relative addressing modes. So in that we have to use base register, base pointer, source index, and destination index. All are 8 bits or 16 bits based upon 8085 and 8086. In that we have to use instruction, that is register and displacement. So displacement is what? Actually it is a effective address only. So that is effective address with the register, and some more address with the source index and destination index. Finally, you have to make detailed summation, and you will get a particular data operations, that is memory data. Okay. So how in this you are going to do as bx plus 4. So it is a relative. You call it as a relative. So offsets for the 4 bits you are going to be add with the bx base register, and then you transport it into CL through the DS. DS in the sense what? It's a data segment. So BX plus 4, you transport it into CL through the data segment. This way you are going to be manipulate register relative addressing modes. Okay. So these things you more clear while we are doing the lab programs. That time you will get more clear. But just now you will go through that theory part. Yeah, fine. Okay. In this way, so direct addressing modes only you are taking values here. Indirect addressing modes, you have take only the register, and in the relative, you take some offset value, that is a 4 number. Okay, 4 number also you have to add it. So again, one more subtype, that is base indexed addressing modes. Here you have to clearly use the indexing, that is source indexing and destination index along with the. So this source index and destination you have to add it with your base register and base pointer. So in the previous, along with that, you are going to use it. Along with that effective address you are going to use it, but here these two you are going to be added, source index and destination index, in the bx and bp, that base register as well as base pointer. It becomes an effective address in the indexed addressing modes. So that format is register is there, instruction is there. In the instructions you have to use base register, base segment, and index register. And also for the base purpose use the one more register. Index, it may be SI or DI, destination index or source index, and finally how to add it, then that effective address is going to be for that data manipulations. So here in this sense, here is the BX. Previous one you are using values here, right? But here you have to use indexing. That's what we call it as based index addressing modes. So here we have to use the index. Only these positions you have to check verify, and you have to get to understand, that is source index addition with the base register, and these two you transferred into C register through the help of data segment. So data segment, it will transfer these two values to the C register uh, in this that based index addressing modes. That is the third one. And in the last one, that is the base index relative addressing modes. So here you have to use displacement with positive or negative numbers also, along with source index and destination index with the base pointer or base registers. So the effective address of an operand is some base register BX or BP and contains index register SI and DI, and the contains and 8-bit or 16-bit displacements with positive and negative. So this is the one more category with the relative addressing modes of indirect. Okay. So here it's same way as BX, BP, SI, DI as the previous one, but 8-bit and 16-bit displacements is going to be added into this. How? That one more index is added with the index register and base is added with the base register and displacement. All these three, base register, index and displacement, is going to be form a effective address in the memory data. Okay. So this is about indirect addressing modes. So next one, we will move to that implied addressing modes. So that example, BX, DI, and 20H, all together you transport it into CL. So you note it as it's a CL. This is a CL. Okay, it is not a cut or removed. So CL is the thing what under the square bracket BX plus DI plus 20H. Okay, so it means that all these are transported into CL register through the data segments DS. Okay, this is all about 4 types of subcategories of indirect addressing modes. So next one, the fifth main category under the data related addressing modes, fifth main category, that is uh, implied addressing modes. So in this implied addressing modes, we have to use set the carry flags. Okay, that is STC. We call it as STC means what? It is a set the carry flag, and CLD means what? It is a clears the direction flag. So sometimes we have to set different types of flags. Whatever we studied, up to 9 flags we studied. So those we are going to be set it, or we have to clear it. So हमें सम कुछ समय में सेट करना पड़ेगा है तो वो हम सेट करेंगे. अगर हम निकालना है तो वो रिमूव CLD clear the direction flag we have to use it in the implicit addressing modes. So this is not that much important, but previous all 4 are important. You have to go through in detail. Okay, so this is all about all 5 data related addressing mode. First one. So one example now we will go through that for the example. So these are the given. Okay, so these are the given. So please, is there any doubts, or am I cleared all those 5 addressing modes, data related addressing modes? Okay, fine. So now we will move to some examples. So these are the given. So we taught about in the addressing mode BX. So the BX value may be this one 0158. Any number you have to take randomly. So for our given purpose. And that DI in the sense what? It is a destination index, which is the value of 10A5, 10A5. And that DS in the sense it is a memory, is nothing but data segmentation. So that data segmentation value is 21000. This is the starting of the memory. And one displacement we taught, maybe the displacement value is IB57, because all are we have to use